then fx is called a rational function. Called a rational function. So it's the same way when you have like numbers, let's say by 3, 3 by 5. These are all rational numbers wherein you have 2 and 3 as integers. Though they need not be integers, they could be rational numbers itself. But yeah, 2 and 3 are some real numbers. Then you have got this as a rational number. This is what, if any number is in this form p by q, then these numbers are rational numbers. Here, this px and qx have to be polynomial functions, and qx need not be 0, should not be 0, should not be 0. Then only this is a polynomial function. So examples of this would be say fx is 2x plus 3 divided by x square minus 4. This is a polynomial function. Then you can have again say 2x could be another polynomial function where this could be x square minus 4 divided by 2x plus 3. This will also be a polynomial function because numerator and denominator both are basically polynomial function. Here the condition would be x should not be equal to plus and minus 2. Here the condition would be x should not be equal to minus 3 by 2. Because in such cases, this the denominator will become 0, right? Same way, the px would be called here numerator, just like the other expression wherein we have this numerator and the other denominator, and qx will be called denominator of this polynomial function. Okay. So now again, here there is a qualification which is again not to we have to bother too much about it, but since it's mentioned in the book, we will learn about this as well. So all rational function in lowest form, rational function in lowest form means what? That if you have two expressions like two polynomials in numerator and denominator, if there is anything common, you just have to take them out, is what they are trying to tell you over here. Let's say you have got gx equals to, say I have got x minus 2 into x plus 2, something like this, and in the denominator I have got x square minus 4. So this is not in the lowest form. If I have to put it in the lowest form, then whatever be the common factor, I have to remove it from here. So if I'm writing this is x minus 2 into x plus 2, and this is gonna be basically x, again x is minus 2 into x plus 2, and this will just go on, and this will become 1:1, and this as well could be termed as a rational function wherein the constant term is there and all other terms are 0. So any polynomial function is also a rational function. For example, if I'm just saying that 2x plus 3, right? This one I can write it as 2x plus 3 by 1. So this is also a rational function. So any polynomial function can be written as a rational function itself. So 2x plus 3 is also equal to 2x plus 3. But here, let's put another better example in for lowest form. For example, say I have got x plus 2 whole square rather, and then I have got x minus 2. So I've got x square minus, say I've got x square minus 4 like this. This is my rational function. Then what I have to do is I have to write x plus 2 into x plus 2. This is whole square, right? This is x square minus 2 square. So I have to write x minus 2 into x plus 2. Now I can take out x plus 2 here. Now this expression x plus 2 divided by x minus 2, this is reduced to the lowest form. Okay. Here this was also a rational function. This is also a rational function. But this is not in lowest form because there are some common factors. Not in lowest form, but this is in lowest form. It's saying something like this, that you have got 2 by 6, and then 2 by 6 is also going to be equal to 1 by 3. So this 1 by 3 is the lowest form. This is also same. These two are same, but just that this is what is the lowest form. Rather, rather than this one. Okay. We are just going to do the sum of rational function. Sum of rational function. So let's remember that what did we do when we were trying to sum up the two rational numbers. So let's say I had 1 by 3 and then I had 2 by 4. So what we used to do, we used to take an LCM of these two numbers, and since these two numbers are co-prime to each other, so the least common multiple will be 12, which is product of these two numbers. Then we used to divide this number by this number, and then we'll get 4, and we will get 4, and then we'll multiply the numerator with this divisor, right? So then we will get 4 here, and then similarly we will divide 12 by 4, we get 3. Then since we got 3, then we will multiply this divisor, uh, uh, so the dividend into 2, 3 into 2, we'll do 3 into 2. So we'll get 4 plus 6 by 12, which will be 10 by 12, and this can be written as 5 by 6. Okay. Okay. The same way, if I am trying to sum up two rational functions, for example, I've got x plus 3 divided by x minus 2, and then I've got x plus 2 divided by x minus 3, something like this. Then what I'll do is, now I have to take LCM of these two, since there are basically nothing common. So I'll have to write x minus 2 into x minus 3. So that will be the LCM of these two numbers. Now if I'm dividing this expression by x minus 2, I'll be left with x minus 3. X minus 3 will be multiplied with x plus 3. So x plus 3 into x minus 3. And then here again I'm going to divide this whatever the LCM is with x minus 3. When I divide by x minus 3, I'll be left with x minus 2. So now I'll multiply x minus 2 with x plus 2. Now when I'm doing this, what I'll get in the numerator is a plus b into a minus b, which is going to be x square minus 9. This is x minus 2 into x plus 2, I'll get x square minus 4. Then this will be x minus 2 into x minus 3. And then I can write this as 2x square minus 13 divided by, again, I can simplify it, or I can just leave it this way, x minus 2 into x minus 3. So this is the way to do the sum. Even the subtraction can be done in the similar fashion. Can you do this x plus 4 divided by, now I'm just going to write x square minus 4. And then I'm going to write here x plus 1 divided by x plus 2. Square minus 4, right? Can I write x square minus 4 as again x square minus 2 square? I'm just looking at x square minus, and then can I write it as x minus 2 into x plus 2 as well? Okay, so let's look at this expression. I'm just going to write it as x plus 4, x minus 2 into x plus 2, and then I'm going to write it as x plus 1 divided by x plus 2. Now when I'm doing this LCM, as you know that I have to do x minus 2 into x plus 2. These are the distinct factors, and the maximum power of x minus 2 is 1, x plus 2 is also 1. So this is going to be my LCM. Now, since the entire thing will be divisible by this, so what I'm left with is in the numerator is x plus 4 into 1, because this will divide us by, everything will be divided in one time. When I'm looking at this expression, this x plus 2 is cancelling this, but x minus 2 I'm left with, so I'll be left with x minus 2 into x plus 1. Now I'll have to again solve it. X plus 4 into 1 is simply x plus 4. Now x minus 2 into x plus 1 has to be multiplied. So first I'll multiply with x. So x into x is x square. Then minus 2 into x will be minus 2x. Then 1 into x will be x. And 1 into minus 2 will be minus 2. And denominator would be x minus 2 into x plus 2. Now I try to rearrange this. So x square, so the highest power I put it in first, so x square in the beginning. Now I'm looking at this, is there is one x over here, there is one x over here, but there is minus 2x over there. So this and this will cancel out together. And then I'm left with plus 4 and minus 2, then it will become x square plus 2 finally. And this will become x minus 2 into x plus 2. So this will become x square plus 2 divided by x square minus 4 again. And I can leave it at this. Okay, this is one way of doing it. But say I could not see this is what it is there, right? I was not able to see this. What I'll do is, okay, I'll write x square minus 4 and then I'll write x plus 1 into x plus 2. Now, even if I'm not able to see, what I'll do is I'll just put x square minus 4 into x plus 2 as my LCM. Now, this expression is cancelling x square minus 4, so I'm left with x plus 2. So I'll multiply x plus 4 into x plus 2 here. And then here x plus 2 is cancelling this, so I'm left with x square minus 4. So now I have to multiply x square minus 4 into x plus 1. Okay. Now, next step, I have to multiply everything. So I'm multiplying x with this x square. Then I'm multiplying it with 4. Then I'm getting 4x. Then I'm multiplying it with 2. I'm getting 2x. Then I'm multiplying it with 2. Then I'm getting 8. Okay. So this is the first expression. Now here x square minus 4 is going to get multiplied. So I'm multiplying with x and then I'm getting x cube. Then I'm multiplying it with 4 minus 4x. Then I'm multiplying with x. Then I'm getting x square. Then I'm multiplying with minus 4. Then I'm getting minus 4. And here it is going to be x square minus 4 into x plus 2. Okay. Okay. Let's write it again. So now x cube highest power. I'm just putting it in front. Then I'm looking at x square here, and then there is one more x square over here. So both of them together they become 2x square. And then I'm looking at 4x plus 2x, which is 6x. And then there is minus 4x. And this is gone. Then I'm left with 2x. And then finally here this is 8, there is minus 4. So this is going to be 4 here. Okay. Now this is what is going to be x square minus 4 into x plus 2. Now, again, I'm able to say there is something I can take common here. So if I'm taking x square common in the first two one, I'm getting x plus 2 here. Then I'm taking 2 common here, then I'm getting again x plus 2 here. Then this is x square minus 4 divided by x plus 2. And when I'm taking x plus 2 common from both of them, what I'm left with x square plus 2. And then I'm left with here x square minus 4 into x plus 2. What will happen? X plus 2 cancels out, and again I will get x square plus 2 divided by x square minus 4. Okay, so this is the same expression which I got over here. Only thing, if I had been able to see x square minus 4 is like this, then I would not have been doing so much of calculation. It would have been much easier over here. Okay. So all this expression you have to get used to it, because these are the things which will keep coming to you now going forward, 10th, 11th, 12th onwards. You have been doing this with respect to numbers. Now you have to do it with expressions also, the polynomials. So the similar thing is going to happen for subtraction also, subtraction of polynomial. So if you have got, say, x minus 2 divided by x plus 2 minus x minus 3 divided by x plus 3, then what you will be doing? You will be taking LCM as x plus 2 into x plus 3. Then you will divide it by x plus 2, you will be left with x plus 3. Then you will multiply x minus 2 into x plus 3. Now there is minus, so you will just put a minus over here. Then you divide it x plus 2 into x plus 3 by x plus 3, you will be left with x plus 2. X plus 2 into x minus 3 you will be doing. Then you will be expanding this. So you will multiply x with x, you will get x square. If you multiply minus 3 with x, you will get minus 2x. Then you multiply with 3, then you get 3x. Then you multiply 3 with minus 2, you will get minus 6. Then you have minus over here, and then you try to expand it. X into x will be x square. X into 2 will be 2x. Minus 3 into x will be minus 3x. Minus 3 into plus 2 will be minus 6. Okay. Now divide by x plus 3 into x plus 3. So this will become x square, this will become plus x, this will become minus 6. Then this will become minus x square. This was plus 2x minus 3x minus x minus minus plus x. This was minus 6. This is minus minus plus 6. Okay. Divide by x plus 2 and x plus 3. The entire thing is going to be x square plus x minus 6 minus x square plus x plus 6. Okay. X square is gone, X square is gone, 6 is gone, 6 is gone, but X remain, X plus 2 into X plus 3. So this became 2x divided by X plus 2 into X plus 3. You can leave it like this, or you can still multiply the denominator and you get to this X square plus 5x plus 6. Okay. So this is how you will be doing the subtraction. Only thing you have to see here is that minus sign remains. So subtraction and addition follow the same rule, wherein you have to take the LCM first and then again divide LCM by each of the denominator. Whatever you are left with, the dividend, you multiply it with the numerator and then add or subtract. So this is subtraction. Then we have multiplication. Multiplication again, you have two rational expression like say like 2 by 3 into 3 by 2. This will just cancel out like this and then you'll be left with 1. Similarly, if you have got 2x plus, let's say you've got x minus 2 divided by x plus 2 and you've got another expression x plus 2 into x minus 2. What will happen here? This will cancel out, this will cancel out and you'll be left with 1. It could be also that sometimes it will not cancel out. For example, you've got x minus 2 divided by x minus 3. Here you have got multiplied by x plus 2 divided by x plus 3. So what you do is you multiply the numerator and you multiply the denominator separately. So this will be x minus 2 into x plus 2 and it will be x minus 3 into x plus 3. This will become a minus b into a plus b. It will become x square minus 4. This will become a minus b into a plus b. A square minus b square x square minus 9. So this will be your expression, which is what is multiplication. And then you will have, similarly, you will have division. So remember, how do we do division? So 2 by 3 divided by 1 by 3. What do? We just, when we are doing this, we make this as a numerator and this as a denominator. We flip it, and when you flip it, you will be like, you get 2 by 1. Same thing you will be doing here as well. Say you've got x minus 2 divided by x plus 2, and you will divide it by say x plus x minus x plus 2 divided by x minus 2, for example. Then when you are resolving it, you will put this as x minus 2 and x plus 2. Then this will be flipping upside down. Basically, this will become x minus 2 divided by x plus 2. And what you will be left here is that this will be x minus 2 whole square divided by x plus 2 whole square as well. Okay. So, I mean, just to remember the way it's done for the rational number and follow the same thing here. So, this is all which we had in this chapter. Okay. Let's look at the questions again. What would be subtracted from this to get this? Is what they're asking. Okay. So let's understand this question. So they are saying what should be subtracted from this? So there is an expression 7x divided by x square minus x minus 12. They are asking what should be subtracted from this. So I'm just saying that I will subtract something like a from this to get what? To get 3 upon x plus 3. Okay. So the same thing what you have to do is the way we do in the equation. You send a on the other side, bring this side. So 7x divided by x square minus x minus 12 minus 3 upon x plus 3 equals to a. Okay. Now look at this expression x square minus x minus 12. Can we factorize it? Can we factorize this like this? X square minus 4x plus 3x minus 12 minus 3 upon x plus 3. Okay, so I'm factorizing it, and this becomes 7x divided by, I take x common, then it becomes x minus 4, and I take 3 common, then it becomes x minus 4, then it becomes x plus 3, will be equal to 8. Many times you will not be able to factorize, but here I was able to see that it will be factorized. This will be x plus 3 into x minus 4 and minus 3 upon x plus 3. Now I need to solving it. So I'm solving this. So I'm taking x plus 3 into x minus 4 as LCM. This everything will be stuck out here, so I'll be left with 7x into 1. I'm not writing it. Minus 3 times x plus 3 is actually going to divide it by x minus 4 times, so I'm left with x minus 4. So I'm going to multiply with x minus 4. This is going to be a. Now I'm going to write 7x minus 3x plus 12 divided by x plus 3 into x minus 4 is what is going to be my a. This is going to be 4x plus 12 divided by x plus 3 into x minus 4 equals to a. Let's look at a. It's still simplified. If I'm able to take 4 common, then I'm left with x plus 3 here. And divide by x plus 3 into x minus 4 is what is my a. X plus 3 is again gone, so I'm left with a plus 4 upon x minus 4. So 4 upon x minus 4 is the answer. Question is 18. What should be added to this to get this? Then, so how would you solve it? I'm just going to write the expression. I'm not going to solve it. It's saying that what should be added to this to get to this. So 1 upon x square minus 7x plus 12. What should be added to this? So I'm saying that a should be added to this. To get to 2 upon x square minus 6x plus 8. And to get a, what you do, you send this on the other side. So you get a will be 2 upon x square minus 6x plus 8 minus 1 upon x square minus 7x plus 12. And then solve this to get the expression. Okay. This is being asked, this question is asking you to express this in the lowest form. So you have to see that what can be taken as common and then can be basically can be struck out. So let me just do this one more so that one question you can do. So x cube minus square plus 2x divided by x square y minus 2x square. What can I take common in the numerator? I can take x common probably. When I'm taking x common, it will become x square minus 3x plus 2. And when I'm taking our, I'll be able to take x into y common here. So I'll be left with x minus 2 here. Okay. So x is gone. Okay. And can this be further reduced? So again, looking back, this can be factorized further, like a minus x minus 2x plus 2 divided by x minus 2 into y. So this will become, if I'm taking x common, then will become x minus 1. And I'm taking 2 common, this will become x minus 1. And this will become x minus 2 into y. Again, taking x minus 1 common, I will be left with x minus 1 into x minus 2. This will be x minus 2 into y. Now x minus 2 is gone. I'm left with x minus 1 into divided by y. So this is the lowest form of this. So x minus 1 by y, I don't know.